Right, we'll go through a few stoichiometry questions here. So, 2018, there's one of the, obviously in the short questions, there's nearly always a wee stoichiometry one in the short questions. Here they ask you to find the empirical formula, giving you this bit of information. So they told you what percentage of the compound was carbon, what percentage was hydrogen, what percentage was oxygen. So as always what we do in these, change the percentages to grams, we're taking it as 100 grams, and go back to moles. So when you're going back to moles, remember, we're just using part of the triangle mass in grams. To go back to moles, you're dividing by the relative molecular mass, or the mass number in this case. So find the number of moles of carbon. So it's 54.5 grams divided by its mass number, which is 12. Find the number of moles of hydrogen. .1 grams divided by its mass number gives me 9.1, the number of moles, and then the number of moles of oxygen. So 36.4 grams divided by its mass number, which is 16. So throw each of these into your calculator. .54, 36.4, 2.275. Now, as I said in the videos before, you'll never write a formula as C4.54, H9.1, O2.275, because your empirical formula, if you look at the definition, is the simplest whole number ratios. They're not whole numbers. So what you do is you divide by the smallest and hope that it goes into each of these. So the smallest in this case is 2.275. You divide that, you get 1. 4.54, probably be 2. 1.99, yeah, so 2. And 9.1 divided by 2.275 is 4. Just show you we divided each by the smallest number. I'll just say 2/8 there. And that gives us our whole number ratio of C2H4O. That's the empirical formula. The simplest whole number ratio of the atoms present. The next thing here is a difficult one in 10C. So in 10C, they give you this equation. You must have a wee read at it here. They said when a rusty object was coated with phosphoric acid, all of the rust, there's my rust there, on its surface was converted to iron phosphate. So all of this rust was converted to this. Now in any of these questions, before you even start, you could always write down the molar ratio in which they react. So it's 1 is to 2 is to 2 is to 3. Whatever piece of information they give you, find the number of moles of it. Don't be put off by the way it's phrased. So the iron phosphate formed was found to have a mass of 4.53 grams. Straight away, if I didn't know what I'm doing, I find the number of moles of this. And then I plug in the number of moles back into the balanced equation. You know, you'll generally be right. How many moles of iron were removed from the object in the rust treatment process? That's basically asking you how many moles of this are formed, because all of the rust was converted to iron phosphate. So all of the rust was converted to this. So we have to find, as we suggested, the number of moles of that iron phosphate. So you're going to have to get the relative molecular mass of FePO4. So iron is 56, transition metal. Phosphorus is 31, and you've got 4 oxygens. And when you tally them up, you get 11, 6, 7, 12, 15, 151. Is that right? .151, yeah. Now, again, we're using this part of the triangle over here, giving me the mass in grams. To go back by moles, divide by the relative molecular mass. So 4.53 grams divided by the relative molecular mass, which is 151. Which gives us 0.03 moles. Now what you could do, which I always do myself, sub in this into the molar ratio. So if I know there's 0.03 moles here, There's also 0.03 moles here because the ratio is the same. We halve it to get the number of moles of this, so 0.015. Once you go back to the 1, it's easy to go up to the 3. Times that by 3 and we get 45, 0.045 moles. Now we can answer any question based on that. All going well. Part 2. What mass of rust was adherent to the object before the treatment? They're just asking you what mass is there of that iron oxide. It tells you all of the rust taken as Fe2O3. So we want to get the mass in grams of this. So we've got the number of moles, which is 0.015. We just need the relative molecular mass, because you're going from moles to mass in grams. So you're multiplying by the relative molecular mass, Fe2O3. So 2 times 56, 3 times 16, 160. No units in that, because how many times heavier it is than a 12th of carbon 12. So and we get 2.4 grams. Third part, difficult. Third and fourth part are difficult to be fairly. What was the minimum volume in centimeters cubed of a 6 molar solution of phosphoric acid? So there's my phosphoric acid there. I needed to remove all the rust. So again, I don't really know where I'm going with this, but we always have a set way of dealing with these things. Now what I would say there, they've given me it's 6 molar. And like in my titrations, once I see that big M, that means 6 moles in a litre. Now how do I say that in maths? 6 in 1,000. Because remember, 1 litre is equal to 1,000 centimetres cubed. So that's what you're doing in titration. Generally then, you'd multiply it by its volume and you get the number of moles. So some of you might have learned there's a formula, volume in centimetres cubed, the number of moles, volume in centimetres cubed by molarity divided by 1,000. I generally just work with this. So when I give the molarity, it means 6 over 1,000. Then you generally multiply by its volume, and that gives you the number of moles. Now they've asked me for the volume. I know the number of moles from the molar ratio. So I know that this number of moles is 0.03 from up there. So now I just have to manipulate that. 6 over 1,000 by the volume is equal to 0.03. You can multiply top by top, bottom by bottom. You could do your 6 over 1,000, whatever way you like. 6V over 1,000 is equal to 0.03.